Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem. So the problem is maximum product subarray. So we are given an array that contains positive and negative integers. This is important, negative integers may contain 0 as well. Find the maximum product that we can get in a subarray of an array. It is guaranteed that the answer fits in 32-bit integer. So in this question we are given an array that might contain positive and negative integers 0 as well. So we need to find the maximum product of any subarray that we can get. So subarray is a continuous part of an array. So in this problem, let's say the example is -2, 6, 3, -10, 0 and 2. So we can see that the subarray 6, 3 and -10, the product of these numbers will be 180. So this is the maximum product that we can achieve for any subarray of this array. So if the brute force approach will be to iterate over all the subarrays and find the sum and get the maximum sum. So this will be big of n square complexity. So the optimal approach will require a big O of n loop. So if the integers are positive, then what we can simply do is we can do the approach that we can find the maximum subarray sum at the current index. For example, while iterating this, if we are standing at -3, we will find the maximum subarray sum ending at this index -3. So the maximum subarray sum ending at index -3 will be -2, 6 and 3. -2 into 6, -12 and -3 is 36. So we will follow this approach while iterating over the array. We will maintain the previous maximum subarray product and and considering this current element. So but this approach will not be useful here because our the array also contains negative integers as well. So what we can do is we can maintain two variables, the current minimum and the current minimum maximum as well. So we require minimum as in this problem because uh, for considering negative numbers, if we multiply a negative number by any negative number, the product will be a positive integer. So that's why we require a minimum variable as well. So let's see the code here. Let's first see the an dry run over this array. So let's say we have array -2, 6, -3, 10, 0 and 2. So the current maximum will be after, if we are standing at -2. So this is the first element we encounter. The current maximum and current minimum will be -2. After if we are standing on this index, then the current maximum will be 6 because 6 is greater than -2, and the current minimum will be this current minimum into this 6 integer. So we have the current minimum will be -2, and if we are standing at this index, then we will check the maximum can be the current previous maximum into this element or the current minimum into this element. So here the current element is negative number, so we will get the maximum if we multiply it with a negative integer. So -12 into -3 is 36. So this will be the current maximum, and current minimum will be -3 into this 6, which will be -18. If we are standing at -10, the same here also follows because it is a negative integer. And -18 into 10 is -80, 180, and -3 into -10 into 36, -368. When encountered with 0, the current maximum ending at this index of an subarray will be 0, and current minimum will also be 0. When encountered 2, the current maximum will be 2 and current minimum will be 2. I guess here I have wrote it in it wrong. The current minimum, no, it will be 0 because if we take this if we consider 0, the current minimum ending at its index will be 0 because we will take this subarray. Okay, so let's see the code for this approach. We will maintaining two variables, current minimum, current maximum, and the maximum for the resultant variable. So this will be initialized with the first element index, and these two variable will be the 1. So while we will iterate from 0 to the n, and the new current maximum will be maximum of the current index, because we don't want to take the previous elements. So current maximum will be among the current element we are standing at, or the maximum of current maximum into the current element, or the current minimum into the current element. This will be helpful when the r integer is negative. So if the current minimum is negative and the current index element is also negative, then two negative result in a positive value. So this value might be greater than the current maximum into this area of I. So that's how we will calculate the new current maximum, which we will assign later on the current maximum. So the maximum will be the maximum of maximum element in the new current maximum, and current minimum will be equal to the same logic here also follows, the current element index or the minimum of current maximum into the area of I, or current minimum into the area of I. So after that, after the big O of n loop, we will get our maximum and we will return this answer. So guys, if you find this video anyway helpful, please like this video and share your thoughts via comment, and subscribe to the channel. It will be very helpful. Thank you.